Alright. So partition of a line segment notes. Partitioning a line segment. Definitions at the top. To partition. It's two T's. To partition a line segment means to divide the line segment into a given ratio. The two numbers in the ratio must add together to equal the total number of pieces. Oh, my bad. Why you didn't tell me I wasn't focused? There we go. Now to stop doing that. Y'all know enough about oh, that's the other reason why we're doing this unit too, because y'all learn ratios in this unit. To do it, like I said, to do it at the beginning of the year is kind of aggressive. It makes sense in this unit, but you can't tell people downtown that. Alright. Oh, down here we're just going to talk about ratios and splitting and part versus whole type thing. So it says label point P that partitions the line segment AB, which is this line segment, into a ratio of 3 to 2. So they want you to split this line segment into 3 pieces versus 2 pieces from A to B. So going from A to B, my partition point would be here. P. And I'll do my split on top, showing you 3 segments versus 2 segments. That split. So I split the line segment 3 to 2. And Savion, how many segments do we have in total?
5.
Thank you. If you wanted to know that, this is what they're talking about up top. Add the total number of pieces together, and you'll get your number of segments, which is 5. The next one, we're splitting it 1 to 4. Partition point is here. And obviously our total is still 5. We just partitioned it differently. We did a 1 to 4 split. Next one, 2 to 3. Obviously you can go ahead of me. Yeah. Partition. That's easy because it's not on the graph and it's all straight. Obviously, we're going to do this on the graph. Y'all should know where this is going. Next thing. Determine the ratio of the directed line segment AB when partitioned by point P. So, now they give you the partition point. They just want to know the ratio. Savion, what's the first ratio?
1.
1 to what?
2.
1 to 2. Good. Miss Welsh, what's the second ratio?
2 to 3.
Say it again.
2 to 3.
Thank you. Zoe, what's this third one? 5 to 1. Easy. Alright. So that's just doing it with a simple line segment. Like I said, we're going to go on the graph though. The process is still the same, it's just that you're on the graph now. You have to be exact too where your points are. We want to know the exact location of points too, so we're going to do a little bit more math, but it ain't going to get too much harder than this. Only a couple of them be hard when we get to the practice, just like maybe 1 or 2. It's because y'all got to deal with fractions, and some of y'all bad at fractions, but I'm going to try to make you a little bit better today. We're going to find out. Coming down. Partitioning of a line segment on the coordinate plane. The steps. Step 1. Divide the total number of parts of the line. Hold on. I read that all wrong. Determine the total number of parts the line is divided into. Yeah. Like we did up top, basically. We found out the total number of parts was 5, 5, 5. Just find out your total number of segments, basically. The step 2, determine the length of the horizontal and vertical distance from the end point to end point. Step 2 should sound familiar to y'all. That's when, in other cases that we've done on a graph, that's when we make our right triangle. So if we're going to make a right triangle, and you can even put that under step 2, make a right triangle. This is when we're going to do it. My bad. Step 3, divide each length by the total number of parts found in step 1. So we're going to take, once we get those two lengths, our horizontal length and our vertical length, we're going to divide them by the number of segments that we have from part 1. And then 4, we're going to count from either endpoint the number of parts used to form the ratio. Yeah. The steps are all cute, but until you see it, you won't understand what the words mean. Of course, you got to see it done. But these are the steps. So. Alright, let's do a couple. Number 1, given the points A 3, 4 and B 6, 10, find the coordinates of point A on the directed line segment AB that partitions A to B in the ratio of 2 to 1. So all that reading up there, the main thing you need to catch up there is which way they're telling you to partition your line. They'll tell you which way to go. On this one it says AB, and a lot of them will say it from A to B. Make sure when you start partitioning your line segment, you go whichever direction they tell you. This one says A to B. If you look at number 2, we tell you specifically to go from B to A. You need to make sure you go that direction when you start, and I'll show you what I'm talking about when we get it on the graph. First thing, before we even graph, let's do what they told us in step 1 of the notes. We need to determine the total number of parts of the line is going to be divided into. Billy, the ratio is 2 to 1. How many parts are we going to have in this line? Yeah, 3, right? So you're going to see 3 segments. Y'all can write that up here if y'all want to. That's usually how I start. I always determine the number of segments I'm going to have, because I'm going to end up using that number later. Alright. Which side do I want to start on? Maybe I'll go on this side. Didn't leave out a lot of space, but it ain't going to be too much work on the easy ones. So you'll be okay. Next thing you want to do, let's graph this segment AB. So 3, 4. And then 6, 10. Got A to B. Now, of course, we're going to start you out easy, but I'm going to still show you all the proper work that needs to be done if you want to get these right. A to B. Alright. Oh, I'm tripping. Next, we want to get our horizontal and vertical distance from A to B. So we're going from A to B. Make sure you're going from A to B. You do your stuff correctly. From A to B, I'm going to go this way horizontally, and I'm going to go this way vertically. And usually I tell y'all positive and negatives don't matter, but it does matter on this. So make sure if we're ever going in a negative direction, if we go down or to the left, we indicate that. And I'll show you on the next problem what I'm talking about. On this problem, from A to B horizontally, we move to the right 3. I think everybody should know that. And then we moved up how many?
6.
So this is positive 3, positive 6. Alright. So this is my horizontal and my vertical movement. I always do horizontal first, but it's really up to you how you play the game. Out to the side here, my horizontal movement was 3, Now I'm going to leave a little gap here because I'm going to do some stuff under that. My vertical movement was 6. So the next step tells us, after we do that, divide each length that we got by the total number of parts found in step 1. In step 1, Billy told us our total number of segments was going to be 3. I'll divide my horizontal by 3, my vertical by 3. Dividing both of those by 3. 3 divided by 3 is obviously 1. I heard that not. 6 divided by 3 is 2. Alright. What this is telling us right here, this is telling us how to move on the graph to partition our points. Now, this is an easy one, so we could easily just do what they're telling us on here and get our points. Let me show you. I'll do it the easy way first. So this is telling me horizontally for my partition I should move to the right 1, and vertically I should move 2. So it's telling me this I should do every time I want to get a partition. So to the right 1 up 2, that'll land me here. This will be a point. And then to the right 1 up 2, this will land me here. That'll give me another point. And then do it again and I'll land on that other end point. So those are my partitions right there. The one I want to find, I want to make sure I split the ratio correctly. The ratio is 2 to 1 from A to B. So I should have did 2 partitions, which would have landed me here at P. Yeah, bro, I'm in the middle of my notes. Video. Oh, I thought you said that one. Okay, that's fine, yeah. Thank you. We're making a video, man. Your patience would have been greatly appreciated. Please watch your mouth. Please watch your mouth too. I don't know. You gonna make me lose train of thought? Give me 1 sec.
You're talking about math work. You don't know?
Back to this. So this will be my point P right here. But let me show you mathematically how you could have done this. Since we're going from A to B, and they want me to partition 2 to 1, so from A, I know I got to do 2 partitions. Oh my God. From A, which was 3, 4, and I want y'all to do this with me. I'm going to show you how to do it mathematically. What I'm going to do, horizontally, remember, that's my change in X. Vertically, that's my change in Y. So this is telling me basically to add 1 and add 2 to those values. Once I do that, I'll get my first partition. So I'm going to say 1P, my first partition, is going to be whatever I get from adding those, which would be 4 and then 6. And then I could do it again. Add 1, add 2. Let's give me my second partition. That's the one I'm trying to get to. Please remember the split was 2 to 1. This will be 5, and this will be 8. So I could do it mathematically this way and figure out what my second partition is. It'll be at 5, 8. But if you want to just do the easy count on the ones like this, I'm showing you both ways because we're going to eventually have to do this because some of our answers are going to be decimals and fractions. At some point, we're going to have no choice but to do the addition to be exact. But on this one, since the counts are even and it's an easy split, we could just do it the way I showed you the first time, go over 1 up 2, over 1 up 2. But if your numbers ever become like decimals or fraction stuff, this is how you add to get what your exact locations are. And I'm going to show y'all both ways on all of them just so you'll know. Alright, so point P, if you even look on the graph, it's at 5, 8. So 5, 8 would be my partition point right here. And then the next one we're going to do is number 2. So go ahead and first label how many segments you have. You should know. And then graph AB, and we'll talk about it. So do that for me real quick. Alright, we're back. So we got a line segment on here. We decided we have 3 segments. The split is 1 to 2. But the thing that you need to pay attention to if you went ahead of me is the fact that this partition is telling us to partition from B to A. So we need to be going from B to A to do our split, not from A to B. If you did it A to B, you probably got it wrong. So since we're going from B to A, that's where I'm going to start at. I'm going to go start at B, and I'm going to work my way back to A with my triangle. So I'm going to come across up here, get my horizontal length. Now, this is what I was talking about though. We're going from B to A. We're going back to the left. We're moving back to the left how many spaces? Anybody counted that yet? 9. So how should I write that? -9. And then from B to A, we're going down. Down how many spaces? -3. That's what you want to represent those two as. -9, -3. Alright. Out to the side, like I said, we don't have as much room over here, but we can still make it happen. Horizontal change for me was -9. Vertical change was -3. I'm going to divide by 3. Divide by 3. Get my two numbers. -9 divided by 3 is -3. I'm going to have to write it under. And then my vertical change, -3 divided by 3 is -1. No, this is just telling me how to move, alright? So like I said, if it's even, you could just count them on the graph. Like these are even numbers, so I could just count them on the graph if I wanted to. It's just telling me, this is telling me how to move. Horizontal is telling me to go to the left 3 and then down 1 to do each of my partitions. And I can do that if I wanted to. I can go back 1, 2, 3, and then down 1. Now, to be honest with you, they told me to split this 1 to 2 from B to A. So once I do, and the only number you really want to pay attention to when y'all doing y'all split is that first number. Because you just got to make sure you go that distance. If it's telling me go 1 to 2, I only got to do 1 partition. So that's the one that I just did. So I'm good right there. That'll be my answer. This is my partition point. I don't even have to do the other one if I don't want. You can, but it's a waste of time. This is the split they wanted me to do, and then that's where they want my partition at. So I just need to read that point, which is 3, 0. Now, once again, if you wanted to calculate this using the points, my starting point B would have been at 6, 1. And then from there, I would have, my horizontal change was -3. My vertical change was -1. So I would have did -3, -1 to this point. And that'll tell me where my first partition was, and that's what I need, because my split is 1 to 2 once again. And so 6 minus 3 would have been, 6 minus 3 would have been 3. And then 1 minus 1 would have been 0. It would have took me to my partition point. That's how you do it mathematically. You can count it or you can do it mathematically. Sometimes you're going to have no choice but to do it mathematically once again, because sometimes you're going to have decimals. The decimal ones you're going to need to do mathematically. And the fraction ones too. You'll see. Alright, do number 3 and 4. Once y'all knock those out, I'm going to come around. And then we'll get to the practice. There's 2 I want to show y'all on the practice sheet just because they... So we're looking at number 4. I thought it was the same as the one I printed last year. We changed this, and I'm glad we changed it. Y'all need to see more of these decimal ones. This is good. So the number of segments on here is 3. They must have got that. And then we need to do our horizontal and vertical count. It says partition it from A to B, so that's cool. So horizontally from A, Going to the right. Anybody did that count? 7? Yeah. So it's a positive 7. And then I'm going down. So how should I write my 4? Negative 4, right? Alright. Make sure you get your horizontal and vertical count, right? Out to the side here. Horizontally, like we said, we had 7. Vertically, we had negative 4. We're dividing by 3 on both. That's not a mistake. I think what's his name did it. Oh, what's 7 divided by 3? 2 point what? Oh, so it's a decimal. Is it a run-on? No, we're not using that then. And this is probably a run-on too. Good. We're not using either one of them. We're going to keep it in fraction form. Am I going to need paper on this one? Probably so. Guess we're showing you right here, which is cool. You may not have enough space on here. You may need to write on another sheet of paper that you might need to attach to your notes. I didn't know we was attacking a fraction as earlier, but this is good. That's one less I have to show you when you get to the other stuff. So when you go in the calculator and you divide and you get a run-on decimal like that, keep your stuff in fraction form. Huh? We're not going to want to change that. Keep it like that. And we're going to give our answer as a fraction too, because it's going to be. Now this is one that like I was saying before, that you can't count on here because your moves are decimals. You can't count that on the graph. You're going to have to get your accurate answer. You're going to have to do it on paper and just give them the answer. Alright. And what they want? 2 to 1 split from A to B? Okay. So we're starting out with point A. Point A was at negative 4, comma 7. Oh, my bad. Shh. And then we're still going to do what we said we were going to do, which was add our horizontal value to X and our vertical value to Y. Horizontal value was plus 7 over 3. And then vertical value was minus 4 over 3. I still can't see. 4 over 3. I'm just putting the fractions out here. And I'm putting them down here for a reason. To be able to add these fractions to these whole numbers, we need to turn these whole numbers into fractions. That's why I said some of y'all not going to like fractions, but it is what it is. I should still remember how to make a fraction a whole number. Need to put a 1 under it. The denominator on both is the same. To be able to add, we're going to have to times both of these by 3. I'm going to have to rewrite. So my new fraction for A is going to be negative 12 over 3. And then for the Y value, it's going to be 21 over 3. All I did was make these whole numbers fractions. Negative 12 divided by 3 still takes me back to negative 4. 21 divided by 3 still takes me back to 7. I just made them fractions that I could use to add and subtract. So it's 7 over 3 adding to that one, and this is minus 4 over 3 that we subtracted from this one to get our partitions. the first partition, when we do that, negative 12 plus 7, what is that? I can't think. Negative 5? Yeah. So first partition is going to be negative 5 over 3. And then 21 minus 4. Shit. Who? 17 over 3. Thank you. My brain ain't working right now. How many partitions we got to do? 2? Okay. Then we got to do another one. Same thing again. Plus 7 over 3. And then minus 4 over 3. Do another partition. Negative 5 plus 7. It's going to give you positive 2. So positive 2 over 3. And then 17 minus 4. That'd be 13 over 3. Yeah. And like I said, we have to keep it in fraction form because it's all going to be run on decimals no matter what. But this is how you will find your points. The second partition point on this line will be 2 over 3, 13 over 3. And I'm going to keep it in fraction form like that and write it in down here. 2 over 3 and 13 over 3. You won't have many that are like this, but you will have a couple that are like this, and we expect y'all to be able to do them. I'm going to show you another one because I know you ain't going to get it off the first one. Because like I said, fractions aren't y'all strong suit. Yeah. And that would be us splitting this line into, and it'd be hard to graph that because like I said, these numbers are decimal. But that point would be somewhere in here. I don't know where. Let me see what the numbers actually be. 2 divided by 3, that's 0.666, so 0.7 basically. And 13 divided by 3, 4.3. So it'll basically be, they're saying the point is about right in here somewhere. It's where that partition point is. Like at 0.6, 4.3, something about right there. But it's definitely a decimal. And it's nothing we can accurately put on the graph and whatever. You have to do it on paper. So that's why I pulled this paper out last week. I knew I was going to need this. I found my paper. Y'all going to need paper today for a couple of y'all problems. Alright. Let me show y'all a couple more that I know are going to hold y'all up. Go to the practice. Maybe I'll keep recording this for now. Number 1 on practice. Not a bad one, but I want to show you this one. It's pretty easy to do too. Let's do this one fast. Alright. Number 1 on practice. Yeah. It says the segment is directed from A to B. The ratio is 1 to 3. That's a split. So 4 segments. And we graphing negative 1, 2, and then 7, 8. A, B. So it says from A to B, so I'm going to the right with my triangle, then I'm going up. To the right, I'm moving over 8, and I went up 6. These are both positive. Positive 8, positive 6. So horizontal change is 8, vertical change is 6. Dividing by 4, dividing by 4. 8 divided by 4 is going to give me 2. 6 divided by 4. If you do that in the calculator, you're going to get a decimal. But this is what one of the ones I call a clean decimal, meaning it's not a run-on. I can use this. I don't have to keep this in fraction form. I can use 1.5. That's not a bad decimal. Let's use that decimal and let's do what we've been doing. Only thing is it's a decimal though, so it's a little bit harder for y'all to count decimals on the graph. I'd rather you just do the math on this one. The split is 1 to 3 from A to B, so all I gotta do is move over one partition from A. So from A, point A, it's -1, comma 2. I'm gonna just do one partition from there. Remember, horizontal change is X, vertical change is Y. So horizontal change is +2, vertical change is +1.5. I'm gonna do that math on that point and get my first partition. I only gotta go to the first partition because once again the split is 1 to 3. So -1 plus 2 is 1, and then 2 plus 1.5, 3.5. This is going to be my point for my partition, 1, 3.5. You might be able to graph that one if you can. Oh, I wrote it down here, 1, 3.5. But so it's saying 1, 3.5 right here. You can see that one. That'll be that partition point right there for the split of 1 to 3. Alright. So that's how to handle a clean decimal. Just add real quick and make it happen. Let's see another one I want to show you. Number 8 is one I can show you on practice. I think there's one more on here I want to show you. Let me reference real quick, make sure I'm showing you everything I want you to see. Oh, Billy had trouble with number 3. Maybe we should do number 3. I ain't trying to do all these though. Hold on. Billy, number 8 might be the better one because it's a decimal too. Let me make sure I just hit everything I'm supposed to though. 4. Yeah, I'm gonna bounce around. Let's do number 8 first since we just did a decimal. Do one more decimal, then I'm gonna do a fraction. And then I'm gonna be done. I don't want to do all your problems for you. Alright, number 8. This is on practice still. It says find the coordinates of P so that P partitions A, B in a ratio of 1 to 3 again. So I only got to do one partition. It says A is -2, -4, and B is 7.5. Yeah. Let's graph that. A, -2, -4. B is -7, +5. A, B, I got room at the bottom. I'll do it at the bottom. Alright, Nikes. So we still going A to B, but this is one of the ones I was talking about. If you notice, A is to the right, B is to the left. So we're kind of going backwards. Make sure you indicate that. So from A to B, the horizontal change going back this way. Horizontal change is going to be -5. Vertical change, we're going up, so that's going to be positive. Yes, +9. Thank you. So we got -5, +9. That's our horizontal and our vertical. So start with my horizontal. I'm gonna do it down here at the bottom. I got a lot of room down here. Let's roll down here. It's -5. Vertical is +9. We're dividing both by, oh, I ain't even write my segments up top. It's 4 segments. 1 plus 3. But dividing by 4, dividing by 4. Once again, we're gonna get decimals. Check to see if these decimals are clean. If it's a clean decimal, we're gonna use it. On this one, Negative 5 divided by 4. That's negative 1.25. I can use that. That's not a bad decimal. Let's use that. It's not a run-on. Y'all understand what I say by when I mean a clean decimal, right? Yeah, the repeating decimals, we don't want those. Alright. That's when we leave it in fraction form, we get a repeating one. Negative 1.25. I got kind of close to that other one, I'm sorry. And then 9 divided by 4, if you get that, you're going to get 2.25. So they both straight. So we're going to keep these in decimal form and use that. From there, like I said, we only got to do one partition because it's 1 to 3 split. We're going from A to point A was negative 2, negative 4. And this is why it's important to make sure you have your signs right over here. Because if you don't have a negative 1.25, you end up adding to that, you're going to be wrong. My horizontal change was minus 1.25, so I need to subtract 1.25. And then I had a positive 2.25, so plus 2.25 for vertical. And obviously you're going to need the calculator, but once you put it in your calculator, you'll see what your answer is. It's negative 3.25, comma, negative 1.75. Yeah. So negative 3.25, negative 1.75. That's telling me where my first partition point is going to be. And like I said, they're both decimals, so it's kind of. I can still try to put that one on the graph. From 0, 0, negative 3, then over like a quarter, and then go down 1.75. That partition point will be about right here. I'm guesstimating, obviously, but I'm just showing you like where it might be on the graph. Around there somewhere. But yeah, the decimal ones you have to calculate to get exactly correct. You can't count those. There's no way to count it. You ain't going to be accurate at all. You'll never give me an accurate answer if you're just trying to count. You have to do the math on the decimal ones, like these down here. Alright. The math has to be done. Let me show you one more fraction one and I'll let you be. Like I said, I'm knocking out all these. It's only like, after I do these, there's only like 3 more that you'll see that'll be decimals or fraction. Everything else will kind of be whole number or clean. I'm just trying to help you out with the harder ones because I don't want y'all to be frustrated. So you'll have an example of how to do those. But the majority of these will come out clean. I'm just doing the ones I know kids struggle on every year. Alright. I'm going back to number 4. Last one I'm going to do. Number 4, I'm going to tell you right now, it's a fraction one. Because it's not going to come out clean. But that's why I'm doing it. But we just did a fraction one on our sheet. We're going to do another one. Alright, number 4. Point P is located on AB such that, the split is AP to PB and 3 to 4. 3 to 4 is my split. Yeah. How many segments is that, Billy? Billy? How many segments is that? 7 segments. So we dividing by 7 on this one. Yeah. I tell you already, dividing by 7 ain't it's telling me it's probably about to be a fraction. A is at negative 9.3. B is at 1/8. 1/8. And they say it was A to B. And all they want is the y coordinate of point P. Well, we're going to find x and y. I really don't have to. We could just work with the y's if we wanted to. If you didn't want to do all that work. But I'm going to do both. And you could just decide for moving on if you want to do the whole thing or not. You'll figure out how to speed yourself up at some point. Alright. So it's told me to go from A to B. So I'm moving to the right. that is 10. It's positive 10. Then I'm going up 5. So 10 and 5. Tell you right there, 10 and 5, you know those ain't going to divide into 7 cleanly. We can do our horizontal stuff out here, but we're going to need a sheet of paper. Horizontal is 10, vertical is 5. My bad. We dividing by 7, dividing by 7. You could put it in the calculator just to see, but obviously you're going to get some run on decimals, something that we don't want. So we're going to leave them like that. So since we're leaving them like that, we're definitely going to need another sheet of paper. And we're going to have to do our partitions on there. The partition is 3 to 4. So from A, we're going to have to do 3 partitions. We're going to have to add these fractions 3 times. Point A was at negative 9, 3. I need to remember that. Alright. So on paper, A was at negative 9, comma 3. Before I write anything else in, why am I forgetting to show y'all this? Before I write anything else in, let's go ahead and turn these into fractions. On those two, on that horizontal and vertical that we just calculated, what was our denominator again? 7, right? On both of them. So here, I'm going to put a 1 under both of these. And I know I need a denominator of 7 for both of these. So I'm going to times by 7, top and bottom. I'm going to manipulate these and make sure they got a denominator of 7 too, so I can add them to my changes that I made on the other page. So recalculating point A after I change my denominator, negative 9 times 7, I can't remember that, negative 63 over 7, and then here's 21 over 7. Alright. Now that I have those, I can take those changes that we had on this page. Horizontal change 10 over 7, vertical change 5 over 7, and they were both positive. So this is plus 10 over 7 here. This is plus, what's the 5 over 7. So my first partition after I do that math, 1p is going to be negative 63 plus 10, negative 53 over 7, 21 plus 5, 26 over 7. Then I can do the next one, second partition. You can keep rewriting those if you want. I just know what they're going to be, so I'm going to just keep doing it. Plus 10 to this again. It's going to be negative 43 over 7. Plus 5 on this side is going to be 31 over 7. And then the third partition, which is the one I need to get to. Negative 10, negative 33 over 7. And then plus 5, 36 over 7. This is the one I need to get to because the split was 3 to 4. So I can stop right here. They only want, they said the y value. So my y value is what? Yeah, 36 over 7. I'm actually, so my answer for this one is going to be 36 over 7. And leave your stuff in proper too. On y'all, I created this homework too. You know, I told you we split them up each unit. I created this homework, so I know on there that I set you up right. I gave you directions on the ones that you got to keep in fraction form. Make sure you keep them as improper fractions. Don't try to do no mixed number or nothing like that. Just keep them as in, like you could type that in like that and it'd be good. 36/7, and you'll be good on your homework. All right.